Camera, camera. Okay. Good morning. Okay. Gmail. Okay. Government Polytechnic Usnabad, Electrical and Electronics Engineering, Digital Electronics. Then Parameshwar lecturer. So I am from Government Polytechnic Usnabad, Electrical and Electronics Engineering department. I thought the subject is Digital Electronics now, and my name is Nand Parameshwar. I am lecturer. Okay. So I want to first of all off my camera. Okay. So today the today topics and objectives of the today class is Boolean function in bit, byte, word, Boolean expression, Boolean algebra, truth table, logic gates. Okay, so in this presentation we don't have the logic gates and Boolean algebra, but today we have to cover those topics also. So this is the second chapter in the digital electronics subject. Okay, so in previous classes we are discussing about only first chapter. Now we are entering into the second chapter. Okay, so Boolean function, bit, byte, word, Boolean expression and truth table. Okay, so first thing is Boolean functions. Our Boolean functions or Boolean expressions the both are the same. Okay, Boolean expression and Boolean functions both are the same. So here we have the example f of x comma y. So x y, these are the variables. Here x plus y bar, y complement. Okay, y bar into z. So this is the function f, and truth table, all possible combinations of input variables, and this is the logic gate, logic circuit. Okay, so first of all, what is the Boolean expressions or Boolean functions? So Boolean function is nothing but we have different inputs, and these inputs are a combination of different logic gates. Okay, so we have to logic gates connections. We have to simplify it into expression form. So that is function. So that function is here y equals to x plus y bar z. So here we have two operations. So all variables are combined with operations only. So those are OR operation and operation, not operation. So these are the operations. So here all possible combinations of input variables. We have also here truth table. Truth table represents the inputs and outputs as well as outputs. how many inputs we have and how many outputs we have, we can see in a truth table. For example, if we have two inputs, how many possible inputs? Okay, in binary we have only 0 and 1. For that, only one input is nothing but we get the one input like 0 or 1. If the input is one input, we have only 0, 1. So those are the possible inputs. If we have the two inputs means 0, 1, 1, 0. So, and also 0, 0, 1, 1. So these are the different types of possible inputs. Let us see. For example, if we have only one input, okay, only one input. So one input, there is only 0, either 1. So these are the possible inputs. But in two inputs, if we have two inputs, there is a possible of inputs is 0, 0, 0, 1, 1, 0, 1, 1. And there is no combination of possibilities with the two inputs. So these are the possible inputs of two inputs. Total 4 types of variables or 4 types of combination we are getting with the two inputs. With one input we only have either 0 or 1, only two possibilities. Okay, if we have 3, we have A, B, C. So in this we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, double 1, 1, double 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the total possibilities of 8 combinations. 1, 2, 3, 4, 5, 6, 7, 8. So 8 possibilities with 3 inputs. Okay, so these are the possibilities of 3 inputs. So however, the output will be depends upon the connection, combinational circuits connections. Okay, so this is about truth table. And next we have the logic circuit. The logic circuit is nothing but we are connecting different logic gates in some manner with OR operation or with NOT operation or whatever it is. Okay, here already we are discussing truth table. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, double 0, 1, 0, 1, double 1, 0, triple 1. These are the possible inputs. So depends upon the inputs how we are getting the output. So that represents the F. Okay, so here clearly mentioned 0 in a blue color and 1 in another color. Okay, so this is about truth table and logic circuit and Boolean function. So next we have binary number system. In binary number system we have 3 definitions. Bit, we already know these words: bit, byte, nibble, word. So commonly we are used to this bytes. If any file is there, video file or audio file, for example it have this for example we have to apply one application. There is a condition: the photo must be the photo should be in less than 100 KB. KB is nothing but kilobyte, or MB, 1 MB, below 1 MB. If the movie the video size is 670 MB or 1 GB. So 1 GB, MB, these are all the measurements of computer memory measurements, simply called memory measurements. For example, we have the scale. So what is the purpose of scale? It measures the length of the table or length of the stool, length of the something, whatever it is. So the length units are cm or centimeters or meters, millimeters, like this. Similarly, in computer memory, in audio files, or we have different files and images, videos, which type of file it is, but it first we have some space, some memory. So that memory is measured in bytes or bit. So kilobytes, megabytes, JBs. So one bit, a bit stands for binary digit, is a single place or position in a binary number. So one bit is nothing but only we consider only one single bit. So that is either 0 or 1. Okay. Bit is nothing but only one, the smallest measurement of computer memory. So that is bit. And nibble is nothing but a 4-bit binary number. 4-bit binary number is nothing but 1001. So here 1001. So here we have 4 bits. So the combination of 4 bits is nothing but nibble. And next byte and 8-bit. 2 nibbles are binary number system. 2 is nibbles is nothing but 4 bits. 4 plus 4, 8. So that's why it is called 8-bit. 8-bit is nothing but 1 byte. And next word is a string of a bits whose size, the word length, may be equal to 1 byte, 2 bytes, 4 bytes, and more. So more than 1 byte is nothing but the combination of more than 1 bit or 2 bits. Bytes is nothing but word. Simply we have the alphabets A, B, C. So the A, B, C are called letters. And for example, we have the word car, C-A-R. C is one alphabet, A is one alphabet, or R is one alphabet. So with this alphabets we can form a word, that is car. So similarly, in same way, in computer memory we have the bytes. With that byte so with that bytes we form the word. So that is combination of 1 or 2 bytes. What that is. Okay. So simply computer bit, either on or off. On is represented with 1 and off is represented with 0. So for that, so on is represented with 1, off is represented with 0. So this 0 can said as 1 byte, 1 bit, bit bit. Okay, or either we can represent with this 1 is also 1 bit. Okay, so the combination of these bits, here we have 4 bits, 4 plus 4, 8 bits. So 8 bits is nothing but byte. If we have only these 4 bits, so this is called nibble. Already we are discussing in last slide, nibble. Okay, so that is nibble. So combination of 8 bits is nothing but byte. Okay, simply here we have 8 bits equals to 1 byte. Okay, bits versus bytes. So this is about bit and bytes. So what is about word? So simply we can write it as, if we have 2 bytes, so this is equals to word, we can say. Okay, if we have 2 bytes or 4 bytes or 3 bytes, one, okay, how many, more than one is nothing but the combination of more than 1 byte or 2 bytes is called 2 or more. The combination of 2 or more bytes is nothing but word. Okay, next, already we are discussing computer memory, units of computer memory. Here we have 1 bit. So 1 bit is nothing but that is only one digit, binary digits, and that is 0 or 1. So that is 1 bit. The 1 bit, 8 bits. In 8 bit we can say it is as 1 byte. Okay, 1 byte. Next, total we have 1024 bytes. If we have 1024 bytes, so that is equivalent to 1 kilobytes. So kilo, so already we are all known the word kilo. For example, how many grams for 1 kilo? So 1000 grams. So 1000 grams is equal to 1 kg. Kg is nothing but kilograms. G means grams. So 1000 grams equals to 1 kilograms. But in this computer memory, we have 1024 bytes. We have 1024 bytes. So the 1024 bytes is nothing but 1 kilobyte. In same manner, if we have 1024 kb, that is equivalent to 1 megabyte. MB, 1 MB, 1 MB. So 1 MB is nothing but 1024 kb. So 1024 MB. So 1024 MB is equivalent to 1 GB. So gigabyte, mega, giga. So normally we are represented with kilo is with 10 to the power of 3, giga is represented with 10 to the power of 6. Okay, 10 to the power of 9 tetra, 10 to the power of 12 peta, 10 to the power of 15 hexa, 10 to the power of 18 zeta, 10 to the power of 21 eta, 20 to the power of okay, so like this. So 1024 GB is equivalent to 1 terabyte. 1 terabyte, already 1 terabyte. Yeah, I'm already knowing. Okay. One terabyte. So 1024 terabyte is equal to 1 petabyte. So 1024 petabytes is equals to 1 exabyte. 1024 EB is nothing but 1 zettabyte. 1024 zettabyte is equivalent to 1 yottabyte. 1024 YB yottabytes is equivalent to okay brontobyte, brontobyte, and 1024 GB is nothing but 1 GOP, highest one. So this is the smallest one, 1 bit. So highest one is GOP byte. So after that we don't have this measurements, 1024 BB only. Okay, so that is the measurements of computer memory. And next we have Boolean algebra. Boolean algebra we have Boolean algebra. Algebra. So algebra is nothing but commonly addition, subtraction, multiplication, divisions. So here we have different types of basic rules of Boolean algebra. Those are a plus 0 equals to a, and a plus 1 is equals to 1, and a dot, here dot represents the multiplication operation. So a multiplication with 0, so that is equivalent to 0. And next we have a dot 1, and that is nothing but a multiply with 1 is nothing but 1, 1 not 1 a. So a into 1 is nothing but a plus a. We have two variables a plus a. So in this, yeah, simply this is can explained with this is only. If we have a plus a, for example, plus 1. Okay, a plus a equals to a, and next a plus a complement. A plus a complement is equivalent to 1. So these are the basic rules of Boolean algebra. So a into a, here also we are getting a. So a plus a, we are getting a, and a into a also we are getting a. Next a plus 1 we are getting 1, a into 1 we are getting a. Okay, a plus 0 we are getting a into 0 we are getting 0. And next a plus a bar we are getting 1, a into a bar we are getting 0. A complement of complement, that is bar of bar, is nothing but a. A plus ab, a plus ab, 1 plus b. Okay, a plus a, we can write it as a only. A plus a bar b, we can write it as a plus b. Okay, a plus b of a plus c, so that is equivalent to a plus bc. So that is the basic rules of, these are the basic rules of Boolean algebra. So in De Morgan's theorem, so we have special class about this only. In next class we are discussing deeply with about De Morgan's theorem. So first of all, look at this. A b bar, a into b bar is equals to a bar plus b bar. Here a plus b whole bar, a plus b whole bar is equals to a bar into b bar. So how these are this theorem. So deeply we are discussing about this theorem in next class. Okay. And next next we have Boolean expressions. So already we are discussing this about logic circuits. In previous slides we are already discussing about this. Okay, this slide and this slide is similar, both are same. But let me check all the topics are covered or not. Boolean function. So Boolean function, the best example is if we have y equals to y equals to a b plus c. Okay, this is the Boolean function or Boolean algebra. So Boolean expression and function is both are same. In this place we have to write algebra. Okay, algebra, already we are seeing all the basic rules of algebra, and we are discussing about truth table also and bit to byte to word. Okay, so these are the today's topics, and one more thing, we have the time, that's why we have to okay. We are discussing about already bit nibble byte okay, but now we are going to logic gates. We are with logic gates now. So first of all, here logic gates. So logic gates totally we have 3 basic gates. Three, two, two. So total 7 number of logic gates we have. So in that 3 3 are basic gates. Okay. So with the help of this basic gates, we have another 2 gates. Those are universal gates. And next we have 2 special gates. 2 special gates. Okay. So totally we have 7 gates. In that we have 2 basic gates, 2 universal gates, 2 special gates. In total we have 7. Okay. So logic gates are categorized in this format: 3 basic and 2 universal and 2 special gates. 7 total 7. Okay. So next coming to symbols, we have here different types of symbols. First one is NOT gate. So we are discussing about NOT gate. Okay. So in NOT gate, so this is the symbol of NOT gate. NOT gate is nothing but if we have A as input, we are getting the output is A bar. So that is simply, if we have inputs 0, we are get output as 1. If we have the input 1, we are getting output is 0. So these are the inputs and these are the outputs. So this is the NOT gate. So we are replacing this NOT gate. How the table, truth table. Let me check. So this is buffer. This one is buffer and this one is so the inverter is nothing but not gate, and buffer is nothing but if we have the 0 input we get 0 only, and if we have the 1 input we get only 1 output. Okay, and the not gate, AND gate, OR gate, these three are called basic gates. So already we are discussing the 7 types of logic gates we have. In that 3 basic gates, those 3 are AND gate, OR gate, NOT gate. So here we have NAND gate and NOR gate also. So NAND gate, NOR gate is these two are called universal gates, and XOR gate and XNOR gate. So XOR gate and XNOR gate are special gates. So here we have discussed AND gate. AND gate, in AND gate, if the both inputs are high, then only we are getting output high. Inputs are high, రెండు inputs high ఉన్నప్పుడు మాత్రమే మనకి high input వస్తుంది, high output వస్తుంది. So this is the basic theorem of AND gate. So the inputs are 0 and 0, we are get output 0, 0 and 1, and output is 0, 1, 0, 0 only, and G11, when the inputs are high, so both are high, then only we are getting the output is high. Quite different, quite opposite to this AND gate, we have OR gate. So look at the OR gate. That OR gate, so see the symbol of AND gate is like D, output and input, 2 inputs. So in OR gate, when the 2 outputs are low, if we get 2 outputs are low, then only we get output low. So in remaining all cases we get high output. So that is 0, 1, 1, 0, 1, 1. Okay. So in AND gate, outputs high, inputs high, then only output will be high. In OR gate, inputs are low, then only we get a low output. Okay. So this is about OR gate. OR gate symbol is like this, just curved one, and it's like this. Okay, so this is about AND gate and OR gate and NOT gate. So next coming to NAND gate. In NAND gate, the complement of AND gate simply is NAND gate is nothing but combination of, okay, NAND gate is nothing but combination of NOT gate plus AND gate. NAND gate plus AND gate is nothing but we are getting NAND gate. So this is the NOT gate, NAND gate. Similarly, NOT gate plus NOR gate. Okay, so this is NOR gate. So combination of OR gate and NOT gate is NOR gate. Combination of NOT gate and AND gate is NAND gate. So first in NAND gate, see the outputs of AND gate 0, 0, 0, 1. Outputs of NAND gate 1, 1, 1, 0. So if we apply the outputs of the AND gate to the NOT gate, AND gate plus NOT gate. So what is the purpose of NOT gate? If we have the 0, then we get 1. If we have the 0, then we get 1, 0, 1. Here we have 1, So then we get 0. So and plus not. So ఇక్కడ సింబల్స్లో ఇక్కడ AND గేట్ తర్వాత ఇక్కడ మనం వీ హ్యావ్ నాట్ గేట్ హియర్. సో AND గేట్ అవుట్పుట్స్కి నాట్ గేట్ అప్లై చేస్తే మనకి NAND గేట్ అవుట్పుట్స్ వస్తాయి. సో సిమిలర్లీ OR గేట్ అవుట్పుట్స్ ఈజ్ 0 1 1 1. సో OR gate outputs 1 0 0 0. So OR plus not is nothing but NOR. Okay. Okay, and next we have the two special gates in green color. Those are XOR gate and XNOR gate. So XOR gate is nothing but here in XOR gate, when the same inputs, if we have same inputs, then we get low output. Different inputs, same inputs means 0 0, we are getting 0. 1 1, these are the same inputs, we are getting 0 output. 0 1, so different inputs, we are getting output high. 0 1 1 0, different inputs, we are getting output high. So this is the logic of this XOR gate, XOR logic gate. So what is the logic here? If we have same inputs like 0 0 1 1, then only we are getting low input. With the different inputs, we are getting 1 1. So and opposite different. If we have same inputs, we are getting here high output in XNOR gate. Okay, so ikkada see once, here we have XNOR of XOR of B, A of XOR of B. So A of XOR of whole complement. So combination of XOR plus NOT gate is nothing but XNOR gate. Okay. So once see the inputs and outputs of XNOR gate. In XNOR gate, what is the logic? Here if we have the same inputs, then we get output is high. With the different inputs, we are getting output is low. Okay, so 1 1, we are getting output is high. 0 1, we are getting output is low. 1 0 1 0 also 0. 1 1, we are getting 1. So this is about XNOR gate. Okay. So total gates are 7 gates. So in this paper, 7 gates: NOT gate, AND gate, OR gates are the basic gates. So for NOT gate, what is the logic? Output is low, input is low, output is high. Input is low, input is high, output is low. So that is the logic of NOT gate. And AND gate logic is, if the inputs are high, 2 inputs are high, then only the output is high. Remaining cases, the output will be low. So what is the OR gate logic? When 2 inputs are low, then only the output is low. So this is the logic of OR gate. And these 3 are called basic gates. And we have NAND gate and NOR gate. So So NAND gate is nothing but combination of AND gate and NOT gate. AND gate and NOT gate, simply AND gate outputs plus NOT gate, we are getting NAND gate. So and the logic is, when two outputs are high, the output will be, and then the two inputs are high, the output will be low. So this is the logic of NAND gate. And for NOR gate is nothing but it is a combination of NOT gate plus OR gate. Okay. So in this logic, when two inputs are low, then only we are getting output is high. When two inputs are low, the output is high. And next, XOR gate. For XOR gate, same inputs we are getting low in same inputs we are getting low output, 0 0 low, 1 1 low. And XNOR XOR plus NOT gate is nothing but XNOR. So in this we have, when the same inputs we are getting high output, in different inputs we are getting low output. So combination of XOR plus NOT gate is nothing but XNOR gate. So XOR gate and XNOR gates are called as special gates. So special purpose we are using these gates. So these are the logic gates and truth tables and symbols. Okay. Okay. Thank you. Thank you for staying at home. Play. Okay, thank you. So today we are covering Boolean Algebra. So in next class, Boolean Algebra, Boolean expressions, bit, byte, word we are discussing. In next class we are discussing logic gates, universal logic gates, how we are using the realization of all gates by NAND gate and NOR gate, that is universal gates. Okay. Okay.
Ready?
Thank you.
Ready.
అవును
అయిపోయింది
బేటా
అప్పుడే క్లాస్.
క్లాస్ అయిపోయింది బేటా థ్యాంక్ యూ